Okay, so we are continuing through exam 1 from fall of 2018, and we're looking at page 2. And we are going to go through and see what we can figure out about these problems here. So question 7, let me zoom in here a bit. All right, question 7, we're doing some unit conversions. And so there's no big, there's no big secret to this. We just need to know what our units are and how to convert from one to the other, especially when we're dealing with our metric conversions there. There's a couple other videos that I've put up to kind of show how I do this. So at least for 7A, take a look at those other videos if you're not quite following along here yet. But we're going from kilometers to micrometers, so kilometers to micrometers. And so what I do, whoops, not 3, 2.13. So 2.3 times 10 to the negative 3 kilometers. I'm going to take this into meters first, right? So for every 1 kilometer, there's 1,000 meters. Now I take meters into micrometers. So for every 1 meter, there is 1 times 10 to the 6th micrometers. And like I said, take a look at the other videos. We talk about how we can kind of flip these fractions around to make it look a little bit differently. But if we do this, we get 2.3 times 10 to the 6th micrometers. Okay. All right. So that one was pretty straightforward. The next one here, if you notice, we've got to do 2 kinds of conversions. We've got to convert grams into kilograms. All right, so we're going from grams into kilograms, and we are going from, let's do this in red, from cubic centimeters into cubic meters. So there's 2 types of conversions we got to do. We're going to take care of those separately, right? So we're going to do, and what I mean by that is we're going to do 2 separate steps to get those done. But before we do that, let's take a look at our cubic centimeters to cubic meters. If you take a look in your notes from lecture, you can see where we talked about this already, but here's a review of what we're going to do. So remember, when we have a cubic meter is equal to 1 meter, right, times 1 meter times 1 meter, right? Length times width times height, right? A cubic, 3-dimensional object, right? Length times width times height. Now, we should know that 1 meter equals 100 centimeters. So what we can say is 1 cubic meter equals 100 centimeters times 100 centimeters times 100 centimeters. Right? So we're just converting each dimension of a meter into 100 centimeters. Right? And so if we wrap this up, 1 cubic meter is equal to, right, 1 times 10 to the 6th cubic centimeters, right, or 1 million cubic centimeters. So follow along with this. Let me just change colors real quick. Green, right? 1 cubic meter, right, means 1 meter times 1 meter times 1 meter. We know that for each meter we have 100 centimeters. And so then we just clean things up and get our conversion factor for cubic meters into cubic centimeters. Remember, 1 cubic meter is not equal to 100 cubic centimeters, right? We can't just cube our units and say that it's equal to what we have up here. So if we're ever asking for multiple dimensions, right? If we're asking for meters squared or meters cubed or meters to the 4th, whatever it is, right? We have to convert each dimension that we're looking at. All right, so let's clean this up. I'm going to erase some stuff here. So keep in mind our conversion factor for cubic meters. Right, we're going to bring this back. Let me see if I can do this here with my... All right, cool. I'm going to drag that over here. Right, and so then we just keep that in mind. Okay. Now, one last thing before we get started. Grams to kilograms, right? So we have to know that conversion too. And now we'll bring that all together. So let's get this written out. So we have 104 grams per cubic centimeter. You can do either conversion first, right? We can convert cubic centimeters into cubic meters, or we can do the grams to kilograms. It won't really matter. I'm going to start with my grams to kilograms. because that's just the kind of guy I am. All right, right? So we're converting grams into kilograms. I'm going to pause here, right? Follow our units. Grams cancels out. So right now, if we just stopped right here, we'd be in units of kilograms per cubic centimeter, right? Let's add in our step. I'll switch to green. Now let's take care of our cubic centimeters. Cubic centimeters is on the bottom over here, so we better put cubic centimeters on the top over here so that our units cancels out. Okay. Let's just double check cubic centimeters with cubic centimeters. And now we're just left with kilograms over meters cubed. Sounds good to me. If we do that, 1.04 times 10 to 5 kilograms per cubic, per cubic meter. So just like with everything in life, take it step at a time, right? Convert our grams into kilograms, and then convert our cubic centimeters into cubic meters. All right. Okay, so C is a little bit different. Still doing a conversion, but now we're not converting our metric units, right? We're converting grams into moles. So we are told that we have 13.4 grams of lithium hydroxide, and we need to figure out moles of lithium hydroxide. Now to convert grams into moles, right? To convert grams into moles, we need either our formula weight, right, or our formula mass. And so we need to know how much lithium hydroxide weighs, so to speak. We need to know how many grams of lithium hydroxide there are for every mole of lithium hydroxide, right? Our formula weight or our formula mass. And to do that, we just add up the individual components, right? We need to look up 1 times the atomic mass of lithium plus 1 times the atomic mass of oxygen plus 1 times the atomic mass of hydrogen. So I'm going to tab over. I've got a periodic table open on another tab, right? So we're going to pull those values over. I'm just going to circle them, right? So I'm going to switch over. I'm going to look for lithium, oxygen, and hydrogen. I clicked on the wrong tab. All right, here we go. Okay. There's the lithium, right? There's our number that we need. Let me make that a little bit bigger just so it shows up, right? There's the lithium down here, right? 6.914 grams per mole, right? Lithium, there's our buddy oxygen, and there's our buddy hydrogen. So we would take those numbers and plug them back into here. So we do 1 times, got to switch back, 1 times 6.904, I believe that's what it was. Let me double check. Oops, 941. 6.941. Okay. Plus 1 times 15.999 plus 1 times 1.008. So just those values that I circled. And if we add that up, I got something around 23.95, give or take, grams per mole. Okay. So this is the formula weight or the formula mass of lithium hydroxide. We just add up the individual components from the molecular formula. All right, so I'm going to just clean this up again. Well, actually, I think I can fit it over here, right? So let's just leave that separate here. So 13.4 grams of lithium hydroxide. For every 23.95 grams of lithium hydroxide, there is 1 mole of lithium hydroxide. And if I do that math, I got 0.559 moles of lithium hydroxide. So the steps for this, right, were to figure out our formula weight and then just do our conversion of grams into moles. A very core, essential conversion that we need to know. All right. So let me just make some space here. Good stuff. Okay, now we've got a conversion of moles into moles for D there. Okay. So to do this conversion, we have to take a look and remember what our formula tells us, right? Our formula tells us that there is one sulfur atom and two oxygen atoms. So if I were holding a mole of sulfur dioxide, I would be holding 1 mole of sulfur and 2 moles of oxygen. Okay, so let me just walk through this real quick, right? If I were holding a mole of sulfur dioxide, of SO2, I would be holding 1 mole of sulfur and 2 moles of oxygen. And so if we translate that idea into a mathematical, or let's say a fraction here, right, a conversion factor, I said that if I were holding 1 mole of SO2, I was holding 2 moles of oxygen. Got it? So I'm just pulling that, I'm pulling this 2 here, right, from my equation there, right? That's part of what our molecular formula can tell us. Okay, so now we just kind of plug in the rest of it. 0.45 moles of SO2. Right, let me just erase this to get it out of the way. Right, our units cancel out. Right, moles cancels out with moles of SO2 with moles of SO2. And so 0.9 moles of oxygen. Good stuff. Another very, very important conversion, going to be extremely useful, or this idea is going to be extremely useful when we start to talk about stoichiometry also. Okay, number 8. So predict all the reasonably preferred charges for the following atoms based on the rules we have covered so far. So right now, all we've learned is a very basic introduction to the octet rule. Remember, I told you guys later on this semester, we're going to expand on that idea. So what I'm asking you to look at preferred charges for the following atoms. All we know so far is kind of how to count to 8 and walk there in the least amount of steps. So I'm going to walk through one example here, and then we'll take a look at the rest of the answers. So let's find phosphorus on our periodic table. Okay. Let me erase our previous marks there. So here's our buddy phosphorus. Right, here's our buddy phosphorus over here. Now, what we've talked about so far is that when, as an atom, for some reason, we don't know yet, we will figure it out, I promise, for some reason they want to get over here to a noble gas configuration, right? We've talked about noble gas configuration. So they want to get to 8 valence electrons is what we've talked about, all right? So we have 2 options. We can walk forward or we can walk back. If I walk forward, right, I have to take 3 steps to get to argon, my closest noble gas. So I can take 3 steps forward or 1 step back, 2, 3, 4, 5. So 3 steps forwards or 5 steps back. So the name of the game is we want to count the least number of steps to get to that noble gas. And so for phosphorus, it's going to be our arrows in green. So 3 steps. So we are going to gain 3 electrons, right? We're going forward. No, that ended up being a little bit, there we go. So 3 minus, right? 3 minus. I'm going to fill in the other ones real quick. I am doing the same thing. Calcium has the 2 plus. Bromine 1 minus. Aluminum 3 plus. Okay. So if you want to pause real quick and see if you can catch up with those answers, how I got those, that'd be great. And I'm going to talk about carbon and zinc real quick. All right, so let's talk about zinc. Zinc is here. Clean that all up. Here's zinc. So what do we know about zinc so far? So it's a transition metal, and it's in our what we refer to as our D block. Now again, we'll talk about this in just a couple chapters, what exactly that lowercase d stands for. But it's a transition metal, and what we know so far is that our D block, or our transition metals, are variant. with their charges. That means depending on what they're bound to and how many things there are, they can change their charge. We know that they're all going to be positively charged. So all of our transition metals should always have a positive charge. And so the question is, well, wait a minute. If you just said that they're variant, how are we supposed to figure out what zinc is? Now remember, there are a handful of exceptions to our variant rule, and zinc just happens to be one of them. So this was just one of these plain questions of, did we memorize our variant exceptions? And zinc is always going to be +2. And you say, well, how am I supposed to know? Or how does that make sense? I don't like to memorize. Those are all excellent questions and excellent points. And I can promise you, as I've said many times, right, we're going to get to our answers. You'll just have to be patient. We have to work up to it. Okay? Now let's take a look at our buddy carbon. This one's a kind of a unique one. So again, switch over to the periodic table. Erase all that stuff. Let's find, there we go, purple sounds good. Here's our buddy carbon. Now you say, well, geez, that's just, there's nothing unusual about carbon, right? Let's test our steps forward and our steps back. 1 step, 2 steps, 3 steps, right? 4 steps to get to neon. Okay, let's step backwards. Black sounds good. 1 step, 2 steps, 3 steps, 4 steps to get up to helium. Huh. So 4 steps forward and 4 steps back. And so the immediate question is, well, what's easier to do? To step forward or to step backwards? And the answer right now is going to be neither one is easier. They're both equally challenging, right? They're both the same. So our answer for carbon is going to be carbon can be 4+, or it can be 4-. And what we're going to learn is it's going to step forward or backwards, either be 4+ or 4-, depending on what else it's bound to. All right, so I'm going to zoom out. That's the end of page 2 here. I'm going to zoom out so you guys can see the answers that I have. And I will make one more recording for page 3. Hopefully I can get that online for you guys soon.